Hi there, this is KOJRO with another video about the 5170 AT project, and it's a lot going on the bench behind me. I do have out my EEPROM eraser to erase some EEPROMs. I have already started to burn some more EEPROMs for the BIOS'es. I'm going to check through all the known good BIOS'es from -0 today, and I'm also going to look into to get this to boot from not the hard drive, but I'm going to use memory card, a compact flash card to boot this, and I'm not going to use an XT-IDE card because the XT-IDE card is a 8-bit card, and even though it doesn't give much penalty in form of performance, I'm going to go with something that fits into the AT bus. I've already rigged up some contraptions back here, so we are going to look into that. So this video I got kind of sidetracked on things, so I will try to keep this video straightforward about getting this to boot from some kind of device that's connected to a compact flash card, and I'm going to run through the known BIOS'es from Avard, Phoenix, Quadtel, the AMI BIOS. So that's where we start out this video. And today we are back at the bench with the AT5170 motherboard, and I promised last time that I will going to test and check out some of the modifications that can be done to this board. And one thing I especially don't like with this board is the inflexibility with the BIOS. And these are the original BIOS chip from back in the day. It's the newest version of the official BIOS for these computers, and they are 23256 modules, and they are marked with the U27 and U47, that is the numbers on the sockets. And there are actually two more available sockets on this motherboard, and they can be used for BIOS extensions and stuff, and maybe we will try some other extensions in this later on. But I was first thinking of putting in one of the more modern BIOS'es into this computer, and when I did the preparation for the fault finding video, I did burn two EEPROMs here with another BIOS. And right off the bat, I can't remember if this was the Avard, the AMI, or the Phoenix BIOS for this. But that we can find out just by putting in these chips and replacing them with those and just see if it boots. But before that, I'm just going to check if this computer is still okay and that it boots okay. So I will just attach a keyboard and I will try to turn this on. And I have this chickeny keyboard here. And you can look the contrast here, that this is seriously yellowed. The cases are yellow, the keys are yellowed on the top, and you can see some water damage. And you can see the cable in contrast with this. Yeah, I don't know how good this shows up on video, but I have tested this keyboard before and it works quite okay. Chickeny actually was one of the quality producers from back in the day, or one of the not top brands, but good and affordable keyboard. And I hooked up this switch here that would tell me if this starts up or not. So I was just going to start this, and it's probably too much light from these overhead lights that you can see what's happening here, but it does count up. Yeah, it does count, and it boots to the diskette error, system options not set, and diskette errors. And I will just try the BIOS'es first, and then I will try to add a battery to this motherboard to see if I actually can store the changes we make. Sorry for the really annoying flickering in the next 2 minutes of video. Yeah, I'm just going to try this out, and I can't remember if I had these out, but I don't think I had. They are marked by the U47 and U27, so I don't need to mark this additional. I'm going to take out my burned EPROMs. I can run into a speed issue with these EPROMs. These EPROMs here are marked with a worst case scenario delay on the data output, and that is the delay between you put the address out on the address bus until you can read the signal on the data bus. And on a 8 MHz AT, this timing needs to be quite fast, and I don't remember the exact numbers, but I do think it was 190, yeah, 190 I think. And these prompts that I have here are 250 nanoseconds. They might be too slow, and they are marked here like this one, that is 25 at the end. And I do have some EPROMs that's marked -150, so if these does not work, or I might, if these are working, I might use some faster EPROMs for the others. But I'm just going to place these in and just check what's happening. And you might have seen my other videos about EPROMs. I might going to make another one because I found another stack of EPROMs. I don't remember when I acquired them, but it's something I got maybe a couple of years ago as an additional catch of EPROMs, and that's quite a lot. But of course the most useful and expensive and biggest types I don't have in much quantity, but the old ones, the 2716 and 2732, those I have in spades. So, new EPROMs. Yeah, I'm just filming off my LCD screen here, so I try to turn this on. It's something happening on the diagnosis, so it's booting in some kind of way. Oh, I can hear the counting sounds. And this is the AMI BIOS, the American Megatrend. Dell, if you want to run setups or diags. I do want to do that. With one to run SEMO setup. Yeah, and I do have a typical AMI BIOS setup, and I don't bother to set up all these installs because I have no boot device attached, and I also don't have the battery attached. So you can see here options for floppy. It's also the 1.44 or not installed, and you have hard drive. And I do wonder if I choose this one because you had a user type or something. Type it's the page up and page down. Here you can actually enter the values for the user defined type. So that's why I choose this BIOS. Save settings and exit. Yeah, I'm going to add some kind of storage device to this, and the easiest thing might be just to use a simple IDE controller and just hook up a compact flash to IDE and see if I can make this work. Yeah, now it's actually stating HDD controller failure, and that's probably because some garbage is in here. So battery first. Then I'm going to add some kind of boot device to this. And I was digging through some of my stuff here, and I took this stuff here. I do have a Cactus. Cactus is an industrial grade compact flash card, and I have a 32 megabyte Cisco card. The size of this disk is actually very period correct. And I also do have a new here industrial card from a Pacer that is just 128 megabyte big. And I do have two different options here. I do have a cable. I couldn't find a true 40 wire cable, just this 80 wire cable that they did later to make this ATA standard faster, and they was able to balance each wire with a ground wire to make the capacity for transfer bigger. But the 80 cable will work just as fine. But I do have this one, and this is just a plug-in card thingy. And I do believe that these cards need the power supply for 5 volt on this one. And I can of course pick 5 volt from this card somewhere and just add a wire. Yeah, I can see here the square pin is here. So this will be, the markings here will be pin 1. This can be connected like so, and I can try to take the Cisco card, for instance, and do like so. But I still need some kind of boot device for a floppy, and I can of course connect some floppy system to this quite directly. I can use a floppy disk, and I also can prepare this card on another computer to make this accessible. But first I'm going to check just if this works and if it's possible to get the system to boot. But I will try to see if I can find some parameters for some of these cards, either this one or this one, and check, because I have to enter the parameters manually in the BIOS. Yeah, I think this battery thingy here will do. When I use it with the normal alkaline batteries, it's going to deliver 4.5 volts, and I do think that's sufficient. I do wonder if these batteries in this was not originally 6 volt or something, but this will do. And I do think that this connector is so that the plus is 1 and 2 here it's connected to ground. And we can actually check that just to make sure by using the fluke here. This should be ground, and yes. So I will just plug this in like so. Then we will have battery. And when it comes to the compact flash card and this adapter here, I will actually have to connect this up to my 386SX test computer to prepare these cards. And I have to use the auto detect feature to see what parameters these cards really have, because I get different opinions of this on the internet, and I do know that these cards can tackle more than one configuration as long as you don't overseed the parameters. But I want to make this right and make sure that I have these cards for future use. So I'm going to just prepare these cards on my 386SX and just use them finished with MS-DOS on this computer. About the parameters of the CF cards. And this is from a website, retrocomp.de, and this table is actually cited a lot over different web pages. So it seems like many users are using this parameter that is here to configure their compact flash cards. But I tried some of these manual parameters and I was able to make them work, but when I put my card into my 386 test computer and used the auto config feature, and this is using the CHS system because it's not compatible with systems that have more than 1024 cylinders. But these parameters is wildly inaccurate if I compare them with what I got. So a 32 megabyte card like you have here, it's 492, 8 and 16, and here it's 60, 16 and 63. So all his system has 63 sectors, but here it's 16 and 32 sectors. And I do think that my cards also will be able to function with these parameters, but if I want to use this across different systems, some of them will have the auto config feature, and also if I plug this into an XT-IDE with a newer firmware, they will use the most common systems for gathering this as auto find, and then it's wise to keep within the auto detect for the CHS. And I have configured both my 32 MB card and my 128 MB card now and installed DOS version 6.22, and this is installed in the 386, so we do have to, there are some HiMem sys and other parameters that won't have been installed if this has been installed on an older system. But it's easy to just edit that out of the config sys. You even can make your own boot menu with this. So these is the parameters that I will configure when we try to test this out on our system. And if we run this with an XT-IDE BIOS, it also will work. But I also did another realization when I was doing this, and I do know this from past experience, that not every one of these adapters are made the same or actually work. And I do have some adapters that works perfectly with the XT-IDE adapters, and I do have some that's only partially working. I do have some that's both able to use the slave and master functionality, and this one was a quite simple one. I do actually have two of these, I think, and it's not working. I was testing this now in my 386 test PC, where I do installation and stuff. I do have a setup going there for installing DOS and other stuff. So I was formatting and installing these cards here, so I would be able to make something boot of this machine even though I don't have a floppy connected. So I switched to another kind of compact flash adapter, and this is a kind that I've used before and I do know to be working, and it's meant to be put on the IO shield on the back of a PC, so it's a very nice setup if you have available some IO space on the back of your computer. And the ironical part about this is if you are buying these from AliExpress, I do think that the whole setup here is actually cheaper than buying just this IO shield piece here. It should be the same, but this actually connects via a cable, and I have not tested this on this card, but I did test it on my 386SX test card, and I did install MS-DOS on this one. And now this system is prepared with the compact flash card and the adapter, and everything of this was working in my 386SX. And I've entered the right parameters in the type 47 in the IMI BIOS. And here I used the parameters that was auto-detected in my 386SX and not the other parameters, and that is because I made a partition with that data. So if I use another set of parameters for this drive, it won't find the sector 0 and the MBR on this drive. And it doesn't work. What you see here is that it's waiting a very long time in the boot up screen, and then it appears that is a non-system disk or disk error, so it ain't able to access the drive. And that might be something with drive translations and BIOS incompatibility. So I will just try the other BIOSes that's available for this card from the -0 degrees webpage. Yes, never have the expression I have been able to see far because I'm standing on the shoulder of giants had more meaning for me, and that is because I'm leaning heavily on the -0 degrees webpage for this 5170 series of videos. And I have a comprehensive list of the original BIOS on all the 51 series of computers from IBM. And they start here with the original 5150, 5155, the portable one, the 5160, the 5162. That is the kind of strange model because it looks like the XT but do have a 286 CPU installed. And here they list several motherboards types. They have identified 3 types of motherboard, even though it's mostly 2 revisions. The 5170 do have some difference in the EEPROMs on the different versions of motherboards, but our motherboard is a Type 3 motherboard, so we do have to use 27256, that's 32K chips. And the original ROMs from IBM, they do contain some restrictions. There are some patches that can be made to avoid these restrictions, but I don't like that I don't have setup utility built into the systems. I don't like the system with a disk, or you can use some generic disk or the IBM original, and you can also use debug and other stuff to program directly into this real-time clock chip that contains this memory that's hold this information. And this is the one that we have tested earlier. It's an AMI BIOS, and you do have an AVARD BIOS. It's slightly older. It said that it's dated in 87. This one was dated in 89. And we do have a Quadtel BIOS, and this is... they are indicating here that it was not meant for the 5170 because they have a speed change functionality. And the 5170 is from the factory a single speed computer. It doesn't have a turbo mode or a void turbo. But it's stated here that it will run on all computers, and it's from Mars 90. And you do have a Phoenix BIOS that is dating from April 90. Even though they do have some 92 firmware something incorporated here. And all of these BIOSes are available for download from this web page, and I have downloaded them, and I'm going to test each one of them to see if they work. And I said that it was possible to patch the original BIOS, and it has been done some, quite considerable work. There also are source code for the original BIOS available on the internet so that you can recompile it. There is also some changes that you can do directly with a hex editor before you burn the prompts to avoid, among other things, that you can't run the computer overclocked. Then the BIOS will tell you, and it's also some changes with using unoriginal floppy and hard drive controllers and stuff. So all these things are patched in the BIOS. And it's also stated there how you should do this, but we are not going down that route at all, because even though how you change this, it does not get you the built-in setup screen that I like to have on my computers. But there are one other major issue that is not fixed by these BIOS patches, and is not fixed by changing the BIOS to one of the unoriginal ones that was compatible, and that is auto-detect of drive, and also to handle drive geometries that is larger than 504 megabytes, and a lot of the cards you get today are larger than that. So I also think we need to look into the XT-IDE BIOS things for and possibilities for this computer. So we will handle that in addition to the common unoriginal BIOSes. And it's stated here that if you use chips that is not ready mask PROMs, then you are going to have some speed bottlenecks, and the 6 MHz Type 1 and Type 2 board, it's okay with 250 nanosecond. And for the first revision, there is also some use cases for 128. I have not looked into that. But some of the motherboards and the EEPROMs are 170 nanoseconds, and it's stated here that you should have a minimum of 190 or maximum of 190 nanosecond access time. And I do think the access time on an EEPROM is defined from when you put data on the address bus, how long it takes for the data is stable and available on the data bus. And I have only tested now with 250 nanosecond chips. That's what I have most of. So probably when they are marked with 260 nanoseconds, they are faster than that because the worst case scenario. And I have not run into problems on this on the AMI BIOS that I have tested so far. But I do have some faster chips, 120 and 150 nanoseconds, but I do think I only have 3 or 4 of those. And the available sockets on this motherboard. On the early motherboards, you can see that they can use 128 chips, and that's the 16 kilobyte variant. But in the Type 2 and Type 3, it's the 256 that are supported. And those sockets, the U17 and U37, are empty as a standard, and they occupy the space from A0 to EFFFF. Segment E are they calling that. And they have those in pair, so that means they do access the full 16-bit data bus, and that can be made twice as fast as other BIOSes that's only access the data bus 8-bit at a time, and you have to make 2 total delays for this to be accessible. And they call these sockets the even or odd or low or high. Luckily, the BIOSes we are going to use here do have this marked on the file, so we don't make any stupid mistakes, or some other stupid mistakes, not these ones. And they also say that this ROM that should be used here should have an 8-bit checksum of 00. And they do have some tips here how you can split and use these files on 2 EEPROMs. You have to split them in high and low, and you do have to burn them separately. And there are a use case here for XT-IDE Universal BIOS for U17 and U37 sockets, and that's what we want. And they tell us just to download the XT-IDE BIOS that we want, but they suggest that we should use the XT version of the bin file. I don't think I will do that because it's a 64K address space, so I don't need to go for the oldest, smallest version. So I'm going to go for this version that I do have here. It's stated that it's an IDE AT and it's an L, maybe it's for large. And it's stated here that it's 9.5K. And I'm going to use that one, and I'm going to use the XT-IDE config to make sure that it fits with the I/O address on the normal controller. And my controller can be both 170 and 1F0. Standard definition is 1F0, so I'm just going to configure it for that and just one controller. So I'm going to use that, and have an 8 kilobit sized USB file for your and has a 8-bit checksum of 00. And this 00 checksum is an important thing because you do have to have a 00 checksum. And luckily, this is an 8-bit checksum. And 8-bit checksums mean that you just add all the bytes on the PROM and you just use the 2 last digits here, or the 8-bit value, to calculate the checksum. And when you have a 0 checksum file, you do have to make sure that the whole EEPROM sums up to a 00 checksum before you are finished. You can actually fill the available space on the EEPROM with zeros, and you will be able to obtain that value. But the normal thing to do is to concatenate the file so that you have several images of the same inside your address space. And that is not a bad thing to do, because if you add 2 files in one EEPROM and each of them have a checksum of 0, the sum will also have a checksum of 0. And in my case, I did use this file here, the AT file, but when I have run this through the config utility, this actually was 12 point something kilobytes. Still not a big deal, but with a 12K image, and you can fill up a 64K address space 2 times 32K. You have to fill out the rest of the EEPROM, and I did that probably not the easiest way, but I can show you that in a minute. And they also tell you that they have utility here that will split the 64K file into high and low, or even on odd files. And this Windows program, I downloaded it. You have to make sure that you allow this to execute, but because it's stating that it's not a valid Windows program, it's not certified by any means, so they want you to make sure to run it. I run it, no problem. Pointed to the file I wanted to split, and it split this quite nicely into two files. First thing you have to do is select an EEPROM that is big enough, and that will be a 27512 kind of chip, because you need it to be able to hold 64K. And then you have to load up the file. And this is the file that I adjusted. It's went to 12 kilobytes. I just load it in from the start. And you can see that it actually contains some data. And you can see here that it's empty at the end. And it stops here at 2FFF with a 90. And this 90 is to make the checksum 0 for this file. And I do need to fill out, because this is a 64 kilobyte file and it needs to be divided into equal parts, and that means that it has to be divided into 16 kilobyte parts. So from here it actually has to be filled, and we can fill it with from starting address, and it's the starting address of 3000 to FFFF. We will fill it with zeros, so they won't affect the checksum. Remember, the checksum was the sum of everything, so if you add a 0, it doesn't matter. And you do have to load in these values that are here again, but the file load feature of the XGQ Pro software and programmer, it's not very good, but it will do the trick. So I have found that the best way to do this is actually just to mark the area, and you just use the copy function instead. So if I go down here and mark this last bit here for 4000, that's the start of our next 16K block, mark this as copy, you mark this cell here and just use paste. Then you will fill it back in here. And now we do have two copies of this. And my two copies of this now ends at 7FFF0 here. So I take this block here, copy, and mark it here, and paste. Now I have 4 identical versions of the same file into this, and the checksum should be okay. So now I can just go on and save this file, and I can save it with the others that I had here, and just call it 64K version 2. And now you have this file here that is 64K, and we have this odd even program. I will just drag it over here, and we find the file that we want to unmix, a file resulting in an odd high and an even low file. And we just take unmix, and he is making 2 files for us. And if we see here, the 2 files is these 2 that is made here. The other ones is the one I made yesterday when I was testing this out. So these 2 files are ready to being burned into 27256 EEPROMs. Now I have done the deed with the EEPROM burner, so I do have a lineup here with EEPROMs. Those that are in the motherboard are the AMI BIOS'es. This is the XT-IDE BIOS'es that we are going to test in the end. We have the Phoenix BIOS, we have the Award BIOS, and we have the Quad-Tel BIOS in these chips. And all of these chips that I've used here is 250 nanoseconds, and that didn't prove to be a problem with these AMI BIOS chips. And it's actually the same kind from Texas Instruments that is used in most of these. I do have two of these are ST branded devices, but the rest of them are Texas Instruments from back in the day. And these ones are of course going into the expansion socket here and is to be combined with any other BIOS. And these I'm going to swap out for the AMI BIOS. Yeah, it's difficult to reach in here with any of my other ship pulling tools, so this screwdriver works just fine. Like so. And I'm going to test with the Phoenix BIOS first. Yeah, this has not been in a socket for some time, so I'm going to use this to align the feet. This is the one for the 47 socket. And this is the one for the 27 socket. I'm going to adjust the legs a bit on these two. Should be good. Yeah, and that was the Phoenix BIOS inserted. Let's see what's happened. And I have the 128 card installed as of now. And we can see that it's booting Phoenix BIOS, base memory, and invalid or damaged bootable partition. I'm going to go into the setup here and see what was it? Was it F1, Alt, Control, Escape? I don't remember what settings was to enter the Phoenix BIOS. I do remember it was Alt Control Escape on some of them and Alt Control Insert on some. Yeah, it actually was Alt Control S on this one, and it does retain the date settings, and it also has kept some of the values for the Type 47 drive, but not the actual values themselves. And there is one drive, I think it's called Custom. Oh, plus and minus, okay. Custom, okay, and here it is the custom for the 128. It's 980 and 8 heads and 32 sectors, like so. Base memory, yeah, that should be okay. And you have the other numlock status, key lock, repeat characters, floppy. You can swap the floppy drives actually, and boot sequence floppy drive, hard drive. I can enter this just as hard drive. I don't have a floppy drive, and the floppy drives are not installed. Video adapter, it's VGA. Keyboard installed. Escape, F4. Exit setup, save values. It's beeping, nothing more. I'm not sure why. This is the exact same I got with with the other BIOSes, I might have to hook up some kind of floppy device to try to boot this to check if there is some, if the drive is accessible at all. But this seems quite the same as with the AMI BIOS. It was hanging on the startup. And non-system disk or disk error after a delay. So exactly the same. And you could see that it actually was accessing the drive light here, so it tried to read from this device, but it was not able to do that. I will try with the Cisco device. And try once more. Oh, that speaker sound was not good. I tried to do a boot and tried to Alt Control Delete, but that didn't work. And Alt Control Escape for the BIOS. Alt Control S, I mean. Keyboard stuck. Key failure. Should actually work into the BIOS anyway. And it's custom, but this time it's 49492 and 8 and 16, like so. And it's the same. I will try with the other BIOSes and see what's happening. Turn this off. But the BIOS in itself was working. So no problems there. Take the award. This. And let's try that. Oh, it's award and it's testing something. I'm not familiar with this startup from award, and I'm not sure here either. They did test a lot of things. Everything they say so far is okay. But this actually stated in this testings that it does not have a BIOS, flexible BIOS type for hard drives. I will try to see if I can enter the BIOS settings on this. Keyboard error or no keyboard present. Maybe that will give me a prompt. Alt Control Escape, and it did retain the date and time and the floppy settings, VGO, EGA. It doesn't matter if it's EGA or VGA, it handles the memory for the BIOS the same. Okay, it has some empty types. That was strange, but it says that you are not allowed to change, and it don't give me the size, only the heads and stuff. And we have nothing that fits here, so we will not be able to boot this anyway. Halt on all errors, that will show speed select, no change, because it doesn't have speed change. So this was a very rudimentary setup, not very complicated at all, but of course you are lacking a lot of features there. This is not my favorite so far, but you do have the customary F10 to record changes. Let's go with that. F1 exits, and we are just going to turn this off, and we are going to test the Quad-Tel BIOS. And the Quad-Tel is not specially made for this this IBM, or at least it does also have some speed change issue things that is not incorporated in this motherboard, because this is a single speed motherboard and the original BIOS does have the limitation that it's software controlled, so it's not allowing for overclock. Maybe a warranty case, or maybe they just didn't want to keep the system on the market for so long that they had a planned expiration date, or maybe they planned to sell their own upgrade. It's not easy to predict what they actually thought back in the day. Yeah, I do think it went okay. This was the Quad-Tel. Quad-Tel is actually the same BIOS that was on this VGA card. Alt Control S, this also. The CMOS checksum is invalid. Okay, it's one of these. It also has the same date setup, and that's okay. Floppy drive. F5, F6, change values. Not installed, fixed drive type. User, cylinders, 9. No, we have the 32 card, so it's 492. Oh, 492. And it 8 heads. And sectors, this is maybe the sectors. It's 16 sectors. The land zone doesn't matter much, like so. And it doesn't seem that you have more stuff in here, but let's just F10 to save. Press any key, escape, exit. And they have extended BIOS feature, auto part hard disk, quick boot, screensaver, keyboard click. Quite the annoying feature that we have to enable. Unblock and F10 save. System information 286, none in coprocessor. They did find the LPT address and the COM addresses. Nice. Park, fix this. Format, fix this. Setups. Escape. Oh, it's booting. So this actually works straight out of the box. So that was nice. And of course it gives us the error that we don't have an extended memory on this. We only have 512K on this computer. But this actually works. So far Quad-Tel is my favorite BIOS. No question about that. But we also have to test XT-IDE BIOS that I made, and then it's no good to test on these ones, because these actually was able to boot, and I do think that these maybe is going back in here when I'm finished with the other stuff I'm going to do here. And I'm going to put the AMI BIOS back, because I do know that what issues I had with this and booting and stuff. So it's only about checking if the XT-IDE BIOS that I made for these sockets, if this is working or not. So, like so. And we had this one. This has also not been in a socket for a while. Yeah, this one bent leg also. These legs that are bent and stuff, it doesn't matter much in the zero insertion force sockets on the EEPROM burner, but of course here they need to be straight. This one looks okay. And I marked this with the odd, even, low and high, and 17 and 37 sockets, so I do hope that I have placed them right. And yeah, just let's go for it. I have to enter the BIOS here, and because I do think I left the tape 47 in here, so we need to enter the BIOS here in the start to get rid of the hard drive settings. This does not like the delete button on the normal keyboard to enter here, but it actually appears to be high. I fill the keyboard buffer with deletes, but this actually appears to hang on startup. Maybe I should give it a go without the XT-IDE BIOS installed to make sure that I have cleared out the CMOS settings. And maybe I need to clear them out because we've made some additional settings now with this Quad-Tel BIOS that might not compatible with the AMI BIOS. So we might need to disconnect the battery also to make this work. It does have the drive access light on, but I do think we need to and just unplug the battery. I don't know for how long this CMOS settings that actually is static RAM that is contained in the clock chip, real-time clock. See if it did forget something. New test. I just wait and see if there is some timeout issues. It's stuck on the diag 7675. And these are not valid codes in my AMI BIOS manual, and they are not codes in the 5170 original BIOS manual, so they don't tell me anything. So we did go into the CMOS setup. It just took a long time, and it did retain, so we didn't have the battery disconnected for long enough. So no drives, nothing. Primary, this could be so, and write to CMOS and exit. No, it won't do anything more than try this because we don't have anything entered on this, so it's just booting like so. Yes, now we are ready to do the XT-IDE BIOS. The 286 chip is actually quite warm. So it's a ceramic package, so it's able to dissipate the heat quite good, but it runs quite warm, even though we have not... Yeah, it's maybe doing some work when you do the memory test and stuff, but It should not be anything that is really hard to compute. Now we have the XT-IDE BIOS, and it should not matter because this BIOS is kicking in after the other BIOS has done its work. And it does not work. Bummer. I do have to check that I do have contacts in these sockets. Oh, there is one bent leg. Oh, this one is almost... But then that was the fault. Then we just turn on again and check that nothing is broken. Yes, that's the XT-IDE BIOS on top, and it's booting. And it did find the slave drive, and yeah, it's the same. So we have learned something here. The reason why I'm not using an XT-IDE as the controller here is that the XT-IDE is an 8-bit device, and IDE and these compact flashes is 16-bit devices. So when you use an XT-IDE card, you are fetching 8 bits at a time, buffer them, and wait 2 cycles to finish a 16-bit word before they are transferred to the CPU. So it's at least just half the speed of what you are able to do with a 16-bit card like this. And the same with the BIOS, because the BIOS in the XT-IDE card is read at 8 bits at a time, and you can of course put shadowing on this and make it fast and read it from RAM if you have enough memory. But this solution will read this 16 bits at a time even if you don't have shadowing enabled. So this way of doing BIOSes is twice as fast as anything you can do with an 8-bit device. So, hope you learned something. We are going to sign out now from the bench, and we are going to do more things with this computer, but now at least we have a fully working booting system that we can make some fun with later on. Yes, this was another long one, and this video I actually have used now about 2 weeks to make it, and it's because I have been traveling, and also because I don't have much time each afternoon to do this this kind of work. But I'm kind of satisfied with this video. But when I did this video, I discovered 2 more topics that I will have to dig into. We actually discovered here that the Quad-Tel BIOS is the best one. I'm going to put this back in the board, and I'm also going to install some more utilities and stuff on one of the compact flash cards and use that as a boot device on this computer when we do the other things. And also I discovered that much of the information that is out there regarding IDE interfaces, setups and other stuff is not very good. It's not very comprehensive, and some of this is flat out wrong. So I'm planning to do a video where I explain some of the basics about the ATA IDE, or what you are going to call it. The last official name of this was PATA, but this video has drained out in some time now, so hope you enjoyed the contents. please hit like and subscribe. Please watch some of my other videos. And do take care, and hope to see you again in my next video. Thanks for watching. Please hit like and subscribe.